Mariana here from my office floor, and I'm going to show you guys how to do the lab at home and do some mark recapture. The first thing to do is try to get a roughly 90-degree angle and mark out with some tape a square. We're going to make a grid. We're going to use 2 containers. This is just a tomato tin that I cut both bottoms off of with a tin opener, and it happens to be 10 centimeters across. So I want 2 containers, one and then one that's half the size. So this is a to-go container that I cut the bottom off, and then I just kept cutting rings off of it until I got a diameter on the bottom of 5 centimeters, half of my 10 centimeter tin. It's not hugely important that it's perfect. We're not publishing this data. It's just following the lab instructions. We would have 2 sampling rings of 2 diameters. When we do this in class, we use 2 rings that are 6 inches and 3 inches, just because these plastic pipes are in imperial measurements, not metric. But these are things that I'm hoping you guys will have at home, where you can find 2 different size containers that are roughly half the diameter. So then we want to measure out a grid system for our 2 containers. So if you put your canister at one end, we're going to measure the larger canister 6 times. One, 2, 3, 4, 5, 6. And then in the other direction, 1, 2, 3, 4, 5. And I've gone off the page, but there's a 6th one here that you guys can't see. Once you have those measurements, you can then continue your grid with parallel lines. Again, I'm not expecting this to be perfect. Do your best. If you've done this right, each one of these grids should be 4 of your smaller ones. 1, 2, 3, 4. And I've set this up where I've put my line as the middle. My line is in the middle of these white squares, white tape. So that's 1, 2. The next thing you're going to need to do this experiment is 2 colors of beans. So I've got some white beans and some black beans. It's not super important what you use or what you have. These are just bags of dried beans. They're pretty cheap at the grocery store. But you could use almost anything. You happen to have lentils, use lentils. You happen to have different shaped screws or nails, use those. You need to have two different things because we're going to use these white ones as our population that we're going to estimate, and then we're going to use these black ones as our marked population. We're going to replace some of the white ones with black ones. Once you have your two sampling containers and you have your 6x6 grid set up somewhere, then you want to take an unknown number of your beans. And you're going to spread those beans out all over your sampling space. You don't want to lose any, but you also don't want to have them be too perfect. So I've just sort of pushed them around my grid. You can see there's a bit of sawdust. When we do this in class, we often will put guinea pig bedding over top so we can't actually see the beans when we do the sampling. But it doesn't matter if you can see them or not. It shouldn't make a difference in terms of your experiment. Now, in the Peterson method of sampling, mark-recapture, we first need to mark some of our habitat. We're going to try and mark about roughly a fifth to a quarter of our population. We don't actually know what the population is, but we're going to try for that many. Don't count your white beans or whatever your first population is. We want to try and estimate it. We'll count at the end. But we just want to try and take out about 20 to 25%. We're going to do this with a random number generator. You can use a paper random number generator, or there might be an online random number generator. I'm going to look that up. Dice work really well. You can use a 6-sided die and roll it multiple times to get the number you need. Or if you happen to be the kind of person who has a 12-sided or 20-sided die, you can use that. The idea here, I'm going to use my smaller sampler first, and that is a 12 by 12 grid. So I need to have a number between 1 and 12. So if I roll my first die twice, I get a 6 and a 2. So I'm going to go across 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. And then 3 and 4 is down 7. 1, 2, 3, 4, 5, 6, 7. Doing this means that I will never have a 0. And that's mildly problematic. But being as 1 would be our first. So like this would be 1. 1, 2, 3, 4, 5, 6, 7. It's totally acceptable way of randomly generating numbers. With a larger die, it's hit 20. So then I'm going to have to roll it again because I want to get a different number. So first, I'm going to take all the beans out of this first one and put them aside. And then this time I've rolled a 1, so I'm only going 1 and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I would keep doing that until I got about half of the beans. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I've been doing these samples. I might have cut out some bits, but I've hit a spot where there isn't any. So I'm just going to keep going. That would be a 0 sample. That happens sometimes. So I have no idea if this is 20 or 25% of the population. I'm just estimating. But now I've done this several times, and I'm going to count how many white beans I have. Once I've counted the white beans I took out, I have replaced those white beans with the same number of black beans. So I've marked my white beans, they're now black, and I'm going to release them back into the environment. And I'm going to let my population mingle, 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 don't roll away, mingle, mingle, mingle. So I've got a distribution of black beans and white beans that are hopefully relatively random, but not at all random because I did it. But you get the idea. Now that we have allowed our beans time to mingle back into the population, we're going to repeat our random sampling, but this time we're going to keep those organisms and count them and record them. So there is a page in your lab manual for recording your marked animals. So I've got 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No, that can't be right because it's a grid of 12. Oh, it's not a grid of 12, it's a grid of 7. 1, 2, 3, 4, 5, 6. Oh no! You guys probably noticed right away, but I only just noticed that I made a grid of 7 by 6. So, please, if you're using dice as your random number generator, it's important that you have 6. Because you won't be able to generate numbers above 12 if you're using a standard 6-sided die. If you have a die like this with 20 sides, it doesn't matter how big you make your grid. But with a 6-sided die, you're going to need a grid that's 6 by 6. So, I'm going to continue on with my 7 by 6 grid, because I'm not redoing it at this point. So in my first square, I have an easy math of 1 red and 1 white. So the number I caught is 2. The number of recaptures is 1. And I don't have any cumulative captures yet because this is my first catch attempt. And my second one's 0. So for my second one, it's 0, 0, and my cumulative, I guess, is 2 and 1. I didn't plan having 2 and 0 as my first two. That really was just random. So this time I've got 2 white and 1 black. So my number caught is 3, my number of recaptures is 1, my cumulative number caught is 5, and my cumulative recaptures is 2. So I'm saving all of my captures on the side here. Got 6 again. This time I've got 2 recaptures and 3 total. bringing my cumulative up to 2, 4, 6, 8, and 4, which so far looks good in terms of getting a population that's half. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I've got a lot in this one. 1, 2, 3, 4, 5, 6, 7, 8 white and 3 black. So that's a total of 11 captures, 3 of them recaptures. And I'm going to keep doing this 16 times. This time I only have white. So my number of recaptures is 0 and my number of captures is 5. I've got 5 total, 1 recapture. You're going to notice as you do this, if you get the same numbers, you're going to have fewer spaces. Once you've done this 16 times and recorded all of your samples, you should then return your beans, mingle them out again, and this time you're sampling with your big one. But because it's a larger sample size, we're only going to do it 4 times. 1, 2, 3, 4. 16 captures, 4 of which are recaptures. Then, once you've done all your sampling, you need to collect up all of your beans and count them so that you can see how accurate your mark-recapture estimation is going to be. So we're going to use our mark-recapture numbers and the calculations in the lab manual to estimate the population of beans that we've been sampling from. Hopefully that estimate will be fairly close to the actual population. In real life, the estimate tends to be fairly close. The more samples you do, the closer you get. At any rate, you will get to see the difference in error between one large sample done fewer times and a smaller sample done more times, which will be an interesting comparison. I look forward to hearing about if you got anywhere close to the actual population of beans. I'm now going to log out and actually count this pile of beans that are on my floor. Yay! See you guys soon.